Hello students, welcome back to our video again. So this one, okay, we just recently finished the exercise 10.1. So on today's video we'll be starting just the exercise 10.2, page number 206. Okay, this is just the initiations of the next exercise, and this exercise belongs to the same chapter, exponential equations. Okay, in other words, we can also that is also indices as the laws of indices that we'll be using on this chapter. So this is the Vedanta axles exercise 10.2. Now let's, without further delay, let's move on to the 1a questions. So this one is very trivial questions. I think most of these students, they already know how to do this. So if you already know that, then just don't waste time on this kind of very trivial kind of question. So you can fast forward. Okay. Now let's move on to 1a. So in 1a you have given a is equals to b power c, b is equals to c power a, and c is equals to a power b. Now in this case you have to prove that a b c is equals to 1. Okay. Now what you do is just so this is the given condition we have given here. Okay, given values or whatever you want to say. This is the given things. Now just use the first one. We have a is equals to b power c, or write a as it is. Now replace the b by, here we have b is equals to c power a. Now replace the b by c power a, and the c is already there. Don't miss that power. Okay, again a is equals to, this becomes a into c, ac, or a is equals to, now just like we have replaced b by c power a, now replace this c by a power b. Replace the c by a power b, but we have ac already here. A is equals to a, now multiply this a b c. So nothing here, power means there is always one. So having the same base, you can equate powers. You will get 1 is equals to a b c, which is proved. Got it? Okay. So without further delay, let's go into number c. So just like in number A, in number C also, we have given some of the, x is equals to, we have 10 times A, and y is equals to 10 times B, and we have x power B, y power A is equals to 100. Okay. Now you have to prove is to prove AB is equals to 1. Now in this case, just try to use this. Okay, so we have x power b, y power a is equals to 100. Now we have the value of x is equals to 10 power a. Replace the value of x by 10 power a. B is already there, don't miss that. And y we have 10 power b, and a is already here, don't try to miss it, and this is 100. So this one becomes a times c, ab, here also ab. Okay, since this is in this is the base in 10, so try to convert this also in base. Express this 100 in terms of base 10. Okay, so 10 power 2, that is 100. Now here 10, now these powers get added, is equals to 10 square. Now AB plus AB, that is 2 times AB. Now having the same base, you can equate powers. So equating power, you will get 2ab is equals to 2, or ab 2 will go into the denominator of the other side, or ab is equals to 1. Okay, good. Okay, so without further delay, let's move on to the number 2a question. So if you have finished this, then okay. If you haven't, just take a screenshot. Now I'm going into the 2a number. Okay. Okay, let's go into a number. If a power x is equals to b power y. So in 2a, we have given some of the here. A power x is equals to b power y. Okay. And we have another b is equals to a square. Then you have to solve x minus 2y is equals to 0. So before starting this, I would like to make you some clarity here. Okay, so in a very trivial situations, what you do is you can just suppose this is a square is equals to 4, right? Okay, in this case, what you do is, if you want to make this, if you want to move this square to the other side, it becomes root 4. Okay, if there is 3, then it will becomes cube root 4. Same wise, if there is 4, it becomes 4th root 4. Similarly, if there is n, then it will becomes nth root of 4. Now this nth root of 4 can be expressed in terms of power. For example, if you want to remove this root sign and want to express this in power, what you have to do is, there is a rule for this, the nth root power will becomes 1 by n. So this is the rule. It means that nth root, any number, any variable, nth root a can be written as a power. In terms of power, it will becomes 1 by n. Okay, the n will go into the denominator of the power. Yes. Okay, now in the same way, so we have given here a power x is equals to b power y. So what you do is, you just use that a power x is equals to b power y, or a, this will becomes if you want to, this will becomes yes root x, right? Okay, a is equals to, now this b power y, if you want to express this in power, it will becomes 1 by x, or a is equals to b power, now this, if you just multiply this, y by x. Okay, so in other words, you can also directly do it in this way. A power x is equals to b power y, to make you easy. So it doesn't it will be better. Okay, for some of the students, if you don't understand, just go in this way. It might be lengthy, but it will make you easy to understand in this way. Okay, you will know the laws, the rules. So if you have already known the rules, you can directly just assume that when this power is moved to the other side variable, this power will go into the denominator, just like we do in cross multiplication. Okay, when this this number is when this variable is, when this a power the power is moved to the other side, it will go into the denominator of other variables power. Okay, that you have to keep in mind, or otherwise you just do by this way, or you can directly do this way. Okay, it's the same. Okay, this one is a shortcut. Okay, after establishing this, after making this, both are same. Okay, now what you do is just use this second condition, and we have what? B is equals to a square. Or now we have a is equals to b power y by x, so replace the value of a by b power y by x, and we have already square here. Okay, or b is equals to b power, now multiply this 2y by x. Now having the same power, you can equate powers. We get 1 is equals to 2y by x. Now cross multiply this, is equals to 2y, or x 2y to the other side, it will becomes minus 2y is equals to 0, which is we have to. Okay, this is how it is done. Okay, so after this, let's move on to the next one, number 2b. So I'm going to rub this. Okay, now number 2b. So I would like to remind you just the thing we discussed earlier. For example, if a power x is equals to b power y, if you want to move this power to the other side, this power x, okay, a power x, this power to the other side, it will go into the denominator of another the variable of the other side. Okay, so this here power x, it is in the numerator. In case now if this power x is in the denominator, let's say this is a power x. Okay, now if this x was like this in the denominator, 1 by x. Okay, in this case this x will multiply, it will not go into the denominator, it will just multiply this 1. Okay, now this 1 by x, it will just multiply the numerator, it will becomes xy. Okay, now in the same way, here we have given a power 1 by x, and we have another b power 1 by 3. So in this case, the x in the denominator, the power of x is in the denominator, it is not in the numerator. If it was in the numerator, then it will go into the denominator of another variable's power. Okay, but it is in the numerator, it is in the denominator, so it will go into the numerator of another side's variable's power. Okay, so if you want to make this a alone here, a is equals to, now b power 1 by 3, it will go into the, not the denominator, it is already in the denominator here, so it will go into the numerator. Now this becomes a is equals to b power 1 times x by 3. So after establishing this relation, so what we have to prove is, we have given another, and also we have another given there, ab is equals to 1, and we have to prove this term, x plus 3 is equals to 0. Now in this way, now here, now you can replace the value of a, and also replace the value of a by b power x by 3, and b is already here, is equals to 1. Nothing power means there is already 1, always 1. So in this case, x by 3 plus 1 is equals to, now this 1 can be expressed in terms of b powers. Okay, when b power is 0, then it will turn into 1. Now having the same base, you can equate powers. So x by 3 plus 1 is equals to 0. Now you can just take 3 LCM, x plus 3 times 1, it will becomes 3. Now 3 times 0, when multiplied to the 0, it will becomes x plus 3 is equals to 0, which we have to prove. This is proved. Okay, got it? Good. Okay, uh, now without further delay, let's move on to the next questions. Okay, so I'm going to rub it. So if you haven't, just take a screenshot. If you haven't finished this, just take a screenshot. Now I'm going to rub it. Okay, let's move on to the number 2C. So in number 2C we have given x power a, x power b is equals to x power a b. Okay, so yes, and you have to prove is a b minus 2 plus b a minus 2 is equals to 0. Now in this case you have to use this. Okay, so that's why we'll use that. We have x power a dot x power b is equals to x power a power b. Now the base is same, we can just add this power. Now here multiply ab, right? Okay, so now here yes, so having the same base you can equate powers. You get into powers, equating powers, you'll get a plus b is equals to a plus b is equals to ab. So after establishing this relation, all you have to do is, in this case, so after after developing this relation, now what you do is you have to prove this part. Okay, now because of this 2 here, you have to multiply both side by 2. Multiplying both sides by 2, what you'll get? 2 times a plus b is equals to 2 times ab, or again right here for the simplification, 2 times a 2 times b is equals to 2 times ab. Now move all to the right hand side. 0 equals to 2 times ab minus 2 times a minus 2 times b. Now just disintegrate this. Okay, just break this down into ab plus ab. You can write to ab is equals to you can break it down to ab. Okay, ab plus ab minus 2a minus 2b as it is. Now distribute this ab here. ab as this minus 2a plus ab minus 2b. Just just arranging. Okay, ab minus 2a plus ab minus 2b is the same. Now after that, because we have to see the terms which we have to prove, according to that you have to arrange the terms. Now in this case you can write, or now here you can take a common here. A, if you take a common there, the remaining inside the bracket becomes b minus 2, plus if you take b common here inside the bracket, a minus 2 is equals to 0. So this is which we have to proved. Okay, so we proved this. So there is another way of proving this. If you find this way easy, you can do in this way. Now there is also another very easiest way. After having this establishing these relations by using this given, you can directly move from this to take the LHS here. LHS equals to, we have here a b minus 2 plus b a minus 2. Now just multiply, simplify this. AB minus 2 times a plus AB minus 2b, or AB, not or, AB plus AB, you can write 2 times AB minus 2a minus 2b, or, not or, is equals to 2ab. Now you can here take here minus 2 common inside the bracket, a plus b, 2ab minus 2. Now a plus b, so here we have established the relations a plus b is equals to ab, so replace a plus b by ab. In this way 2ab it will cancel, it will be 0, which is RHS proof. So which way do you find more convenient? You can prove either by this way or by this way, both are correct. And which which one do you find more convenient, you just do that way. Okay, now without further delay, let's move on to the number D. Okay, let's move on to number 2D. So in 2D we have a power m dot a power n is equals to a power m power n, and we have to prove is m by n plus n by m is equals to mn minus 2. Okay, this is the situation we have here. So in this case, just like we did in the number 2C, we just use this. We have a power m dot a power n is equals to a power m n, or a power m plus n is equals to a power mn. Now equate powers, you will get m plus n is equals to mn. Now in this case, in the previous 2C questions, we have we multiplied both sides by 2. Yes. Now in this case, not the same thing. Okay, here not the it will not be proved by the same way we have did in number 2C. So for this we have to use some different way to prove this part, prove this part here. Okay, so in this case you will do squaring both sides, right? Okay, so squaring both sides, it will get mn whole square is equals to mn, m plus n whole square is equals to mn. Now expand this, m square plus 2 times mn, right, plus n square is equals to mn whole square. Now write this m square plus n square here and move this 2 times mn to the other side. Mn whole square, move this to the other side, 2 times mn, or m square plus n square is equals to, now from here you can take mn common, here is square, now here only remains mn minus 2, right? Okay, after this you can move this mn to the other side, m square plus n square to the left hand side, it will go into the denominator, mn is equals to, here remains mn minus 2. Or now you just separate this, disintegrate this. Okay, so m square by mn plus again n square by mn is equals to mn minus 2, or now square this m get cancelled, it can be written as m by n, and here n square and this n get cancelled, you can write n by m is equals to mn minus 2. And this is how it is done, and it is proved. So if you like this way, you can do it this way. If you want to go in another alternative way, that is by taking LHS. Either do this or by taking LHS from here, from this relations to directly, you can do this in this way: m by n plus n by m. So in this case, you can take LCM mn, and this m becomes m square plus this becomes n square. So here m square plus n square can be written as m plus n whole square minus 2 times mn divided by mn. So m plus n whole square, m plus n can be written as mn. So m plus n, replace m plus n. Here we have established m plus n is equals to mn. So replace m plus n by mn. So there is already square here, 2 times mn divided by mn. Or now here you can take in the numerator, you can take mn common here, and the remaining inside the bracket mn minus 2 divided by mn. So mn get cancelled, the remaining would be mn minus 2, which we have to prove. RHS proved. This is how it is done. Got it? Got it. Okay, very good. Okay, now we'll move on to the number equations. So if you have finished this, that's okay. If you haven't, then you just take a screenshot. Now we'll move on to the number equations. Okay, so I'm going to rub this. Okay, now this will be the last questions for today's video. Okay, number 2E. So this will be quick. Number 2E. So with this, our general section will be finished of this exercise. We have given a power x and b power y, and another b power x is equals to a power y. Now in this case, you have to prove is x is equals to y. So for this, we have a power x is equals to b power y. Okay. Now what you do is make this a alone. So this x power will go into the denominator of other side's power. Yes. So here we have a is equals to a in terms of b. A is equals to b power y by x. Now use this again. Again we have b power x is equals to a power y. So just replace a by, we have already established a in terms of b. Okay. So replace a by b power. Just replace a by b power y by x, and y is already here. So or b power x is equals to b power y square by x. Now having same power, same base, you can equate powers. When you get powers, you get x is equals to y square by x. Now cross multiply, x square is equals to y square. So in this case, you can write. You can directly write, or you can write in this way also. X is equals to, when you move square to the other side, it will becomes 2. This will go into the denominator of this. Okay, or x is equals to cancel. Y power 1 means that is y. X is equals to y, which you have to prove, and it is proved. Great. So this much for today's video. So if you like my video, don't forget to like, subscribe, and share my YouTube contents to your friends if they find this the content more useful. Okay, with saying that, I'd like to end this video here, and goodbye, take care, and stay blessed.